Sir. Good morning, everyone. My name is Ashish Patil, and today I'm going to explain you the topic heat of combustion. And I am studying in EMC2 under the guidance of Professor Rohit Sinha, sir. So to understand heat of combustion, first we need to understand what is combustion. So combustion is a reaction where we burn a substance and it produces heat and light. So here you can see an example, matchstick is burning, and here there are some oxygen particles might be there. So if we provide heat to the matchstick, then it will start combustion, and you can see that heat and light is produced. So what is heat of combustion? Heat of combustion is the burning of 1 mole of substance, or when 1 mole of substance is completely burned or oxidized, the heat evolved is known as heat of combustion. So the definition is given here. It is the enthalpy change of 1 mole of substance when a substance completely undergoes combustion. So through an example, we can see here a reaction is given where 2 moles of ethane is reacting with 7 moles of oxygen and produces carbon dioxide and 6 moles of water. And the delta H for this is given as minus 745.6 kilocalories. So there are 2 moles of ethane, and the heat of combustion we find is for 1 mole. So this delta H will be divided by 2. So minus 745.6 divided by 2 will be the heat of combustion of ethane. So heat of reaction in terms of heat of combustion. So heat of reaction is equals to heat of combustion of reactant minus heat of combustion of product. And here a man is sitting, you can see, and there will be coldness around here. He is in a cold area, and he is burning here. Woods are burning, and heat is produced. So we can say that heat of combustion is an exothermic reaction. Now exception. Now I was told that heat of reaction is always exothermic, but in this case heat of reaction is endothermic, where oxygen combines with fluorine. When fluorine is oxidized, it forms OF2. So we can see that this will form O, and O will form O double bond O, and F2 will form F single bond F. Now why this is endothermic? Because this product we are getting is O single bond F and F. So the energy required to break this bond will be less than the energy required to break this bond will be more than the heat of combustion, and the heat of combustion will be absorbed by this bond to break itself. So heat of combustion will be endothermic in this reaction. So this is the reason why, because, and also oxygen has a valency, or oxygen has a tendency to accept electron, but opposite is happening, that oxygen is getting attached with fluorine here. So that's why this reaction is endothermic. Now the instrument used to measure the heat of combustion is known as bomb calorimeter apparatus. Now here is a diagram of it. This is a container where water is inside this container, it is also known as bomb, and this is adiabatic container, so heat cannot go inside and heat cannot come outside. There is no transfer of heat here, and this is a sample cup where we put the substance which we want to find heat of combustion, and the ignition wires will spark the substance here, and when this will perform combustion, the heat will be absorbed by the water, and since it is adiabatic system, so heat will not transfer inside and outside the system. So the thermometer will measure the temperature of the water, and you will get the heat of combustion of the substance. So the conclusion is that first point, we saw that what is heat of combustion. It is the 1 mole of substance when completely oxidized or burned, and then the heat evolved is known as heat of combustion. Next, we saw heat of combustion is always exothermic, but in the case which I have told you that fluorine oxidizes, then it forms OF2. So their heat of combustion will be endothermic. Next, the relation between heat of reaction and heat of combustion. That heat of reactant is equals to heat of combustion of reactant minus heat of combustion of product. And next we saw that bomb calorimeter is the apparatus used to measure heat of combustion. So the references that I've used for making this are Rohit Sinha sir's notes and module provided by sir. Thank you.